Hello students, in this question we will investigate about the resistor X and resistor Y, and one of them is a constant resistance and the other one is a variable resistance, and they are connected in their separate circuits. So first of all, we have to verify that which one of these statements are made about X and Y are correct. Okay, so I will show you these two graphs separately so we can understand in clear manner. So first of all, let's talk about the current and potential difference graph for the constant resistance. Okay, so this is a graph, and as you see, this is a straight line. Okay, so why this is a constant resistance? So Rx is constant, obviously. Why? Because first of all, the graph is straight line, and secondly, dear students, if you see that there is an equal change in the potential difference with respect to the equal change in the current. So the same concept we applies in the kinematics graphs and in all the graphs that you study in throughout your IB. So we see that the delta I over delta V, that is a gradient of the graph, is not going to change throughout. So which means that delta I over delta V, according to the Ohm's law, should be equals to 1 over R. So 1 over Rx is constant. So if 1 over Rx is constant, it means that the resistance Rx is also constant. So it means that the first statement that is made here is correct. And secondly, now I am going to show you this curved graph, which seems like this. All right. Now, this is a current potential graph. And you know already that the slope or the gradient of this graph is equals to 1 over resistance. Since we are examining the resistance for the Y, so that is Ry. Now dear students, I want to show you here the few points so you can dive in deep and understand what is happening with the resistance of this wire. So let us draw the tangents. So this is the tangent line at this point. Well, you see that it would be a maximum steep line, all right, and this will be a tangent line at this point, and then the tangent line at this point, right? So what you see that the slope of the line or the gradient of the line is decreasing. So which makes this resistance not a constant, not a ohmic, which makes this resistance variable, because Ry can be written as 1 over delta I over delta V. So dear students, which is is the gradient of the graph. So how the resistance is changing, you see that the delta I over delta V value, which is the slope or the gradient, don't you think it is decreasing because this tangent line is becoming less steep? So less steep means that the gradient is decreasing. So we can say that the gradient is decreasing. So that's why the Ry is increasing with respect to the voltage. As you see, the voltage is increasing. With the increase of voltage, the resistance of Y is increasing. So which means that, dear students, this option is also correct. Now let's investigate the third option, which says that excluding the origin, X and Y may have a same resistance at the two different voltages. Well, let me show you in a detailed manner that either it is correct or not. So, so to investigate about this option, I must remind you again that the resistance is equals to 1 over gradient of this graph, which is delta I over delta V. Okay, and the resistance of X is constant. So dear students, the point where the slope or the tangent line, I mean, for example, if I show you at this point, if I draw a tangent line at this point, okay, so which is this one. So don't you think this tangent line is parallel to this line, which is showing us the graph for the resistance X? And in the question, they mention that at that point, at the marked point, the tangent to the curve is parallel to the graph of X. So if the tangent is parallel, if the tangent line is parallel, which clearly means that the resistance of y is equal to the resistance of x at marked point. Okay, because their slope or the gradient is equal. And why? Because the rise over run is same. Okay, I hope you understand. And secondly, there is another, and by the way, if you see that at that point there is the same voltage for the both of them, but there are different currents flowing through both of the resistors. Okay, so first of all, the voltage is same and currents are different. So excluding the origin, x and y have a same resistance at two different voltages. It is obviously wrong because it is same resistance at same voltage. Okay, which means that might be the two resistors were connected in parallel. Okay, like this, the one is rx, the one is ry. Okay, it is variable resistance, so they have a same voltage, this one. So imagine this is which is equals to the emf of circuit. So you see that there is a different current flowing through of both of them, but the voltage is same on both of them. All right, now if you see another point where these two like lines and curve is meeting, intersecting, right? Once again, this is another same voltage where they would have same resistance. Okay, so in the last, I would say this option is incorrect because the two resistors have same resistance at same voltage, like this voltage and like this value of the potential difference. So that's why the only the option A should be correct.